Welcome again to Miss Monts TV. If you're new to my channel, please don't forget to subscribe and watch our other videos. For this video, we will compute for the spring constant of spring number 1 from our experiment before. To watch the previous experiment, you can click the link in the description below.
For spring number 1, we will graph the data we get from the previous experiment. So we will put the deflection in y-axis and the force in x-axis. So the table is the mass in gram, the force in Newton. To get the force, we will multiply the mass times 0.00981 Newton per gram. And the deflection in spring number 1 in centimeters. So we will start with 0. Then, in 10 grams, the force is 0.0981. And the deflection is 3.2. So we will graph it. Then, at 20 grams, we have 0.1962. The deflection is 6.6. At 30 grams, 0.0943 newtons, 10.1 centimeters. For 40 grams, we have 0.3924 newton and 13.4 centimeters. And in 50 grams, we have the force of 0.4905 newton and the deflection is 16.8 centimeters. So we will graph it. For spring number 1, we will compute for the spring constant. To compute for the spring constant, we need to get the slope. So F1 and L1. So the K is equal to delta length 1 divided by the force 1. So that will be 10.1 centimeter minus 6.6 centimeter. Divide by 0.2943 newton minus 0.1962 newton. So we get the slope of 0.035 meters divided by 0.0981 newton. That will be 0.357 meter per newton. To get the spring constant, we need to get the reciprocal of the slope. That is 1 over k. So we will substitute it. It will become 1 over 0.357 meter per newton. Then we will compute the spring constant will be 2.67 newton per meter.
I hope you learned and enjoy our video for today. Please don't forget to like, share, and subscribe.